Peace and greetings, dear viewers. I am Zaid. I hope every one of you is well. I hope you are healthy. I hope your heart is full of curiosity. Today's journey is about a mystery of space, a mystery so deep that even light cannot escape from it. Yes, we are talking about the black hole. But what is a black hole? It is not just empty space. It is not a hole like we dig in the ground. It is a place in space where gravity is so strong that nothing can escape its pull, not even light. This idea sounds like science fiction. But it is not fiction. It is real. It is proven by science. It is proven by decades of study. It is proven by mathematics. And it is proven by direct images in our time. The story of black holes begins long ago. In the year 1783, John Michel, an English natural philosopher, spoke of dark stars, objects so massive that their gravity would not allow light to escape. He imagined this long before modern physics. Then came Albert Einstein. In 1915, he gave the world the general theory of relativity. He explained how space and time bend under the weight of mass and energy. In 1916, Carl Schwarzschild, a German physicist, solved Einstein's equations. He showed what happens when a star collapses. It could create a region from which nothing can escape. That was the first clear mathematical picture of what we now call a black hole. But for many years, people thought black holes were only mathematics. Not real, not possible. In the 1960s, new research changed everything. Roger Penrose and Stephen Hawking proved that black holes could form naturally when massive stars collapsed. By the late 20th century, astronomers began to believe that not only do black holes exist, but supermassive black holes sit at the centers of galaxies, even in the heart of our own Milky Way. Then history was made. In April 2019, the Event Horizon telescope showed the first ever image of a black hole. It was in the galaxy M87, a glowing ring of gas, surrounding the dark shadow of the black hole. This was a global triumph of science. It showed the world that black holes are real. They are measurable. They are visible, even though they are the darkest objects in the universe. Before I move deeper into the topic, let me say something important. This channel is user-friendly. No offensive content. No misinformation. We explain things with respect, curiosity, and authenticity. Now let us step further into the mystery. The mystery of black holes, the way they are built, the secrets they hide, and the role they play in shaping our universe. When we look at a black hole, we cannot see it directly. Why? Because light cannot escape its pull. So instead, astronomers study the things happening around it. At the edge of a black hole, there is a boundary. That boundary is called the event horizon. It is the point of no return. If anything crosses it, a star, a planet, or even a particle of light, it cannot escape. Inside the event horizon, the pull of gravity becomes infinite. All matter collapses into a point of endless density. That point is called the singularity. It is the heart of the black hole, a place where the known laws of physics no longer work. But black holes are not all the same. Scientists have discovered different kinds of black holes. The first type is the stellar black hole. These are born when massive stars run out of fuel. They collapse under their own gravity. The star explodes in a supernova, and what remains becomes a black hole. These are usually a few times heavier than our sun. The second type is the supermassive black hole. These are giants, millions, even billions of times heavier than the sun. They sit at the centers of galaxies. Our own galaxy, the Milky Way, has one called Sagittarius A. It is about 4 million times the mass of the sun. The third type is the intermediate black hole. They are not as small as stellar black holes and not as huge as supermassive ones. They are extremely rare, but scientists believe they form when smaller black holes merge. And then there is the most mysterious category, the primordial black holes. These are only theoretical. Scientists suggest they might have formed in the very early universe, shortly after the Big Bang. They could be tiny, maybe the size of a mountain, but heavier than the Earth. To study these invisible giants, scientists use indirect methods. One way is by watching stars orbit around an empty-looking point in space. If those stars are moving unusually fast, it often means a black hole is pulling them. Another way is by observing light. When matter falls into a black hole, it heats up. It releases powerful X-rays and radio waves. These signals tell us a black hole is present. In recent years, a new tool has opened the universe even more: gravitational waves. When two black holes collide, they send ripples through space and time itself. In 2015, the LIGO Observatory detected the very first gravitational wave signal. It came from merging black holes over 1 billion light-years away. This discovery confirmed another part of Einstein's theory. It showed that black holes are not silent. They shake the fabric of the cosmos. Black holes are not only destroyers, they are also creators. Their immense gravity shapes galaxies. They control the dance of stars. They regulate the birth of new stars through their powerful winds and radiation. So when we study black holes, we are not just looking at something strange. We are looking at the very engines that shape the universe. Black holes sound terrifying, but they are also full of wonders. They bend space. They bend time. They even change how light itself moves. Around a black hole is an area called the accretion disk. This is made of gas, dust, and sometimes even whole stars being pulled inward. As this matter spirals closer, it moves faster and faster. It becomes extremely hot. It shines brighter than almost anything in the universe. This is why some black holes appear as brilliant X-ray sources. Now imagine this. Light passing near a black hole does not travel straight. The gravity is so strong that light curves around it. This effect is called gravitational lensing. It allows astronomers to see multiple images of stars or galaxies hidden behind the black hole. It is like nature's magnifying glass. But what happens if a person or a spacecraft falls into a black hole? The answer is strange. If you watch someone falling in, you would see them slow down. Closer to the event horizon, their image would freeze. They would appear stretched and then fade away, as the light could no longer escape. From their point of view, inside the black hole, time would feel normal. But once past the event horizon, no signal, no sound, no light could come back to tell the story. Scientists call this effect spaghettification. The pull of gravity is stronger at the feet than at the head, so objects stretch out like long strings of spaghetti. This is not science fiction. It is real physics, a consequence of the unimaginable gravity. But black holes also create mysteries. One of the greatest questions is, what happens to information that falls into a black hole? Stephen Hawking proposed that black holes slowly evaporate through something called Hawking radiation. This radiation leaks away energy, and over unimaginable time, the black hole disappears. But here lies the paradox. If the black hole vanishes, does the information vanish too? In physics, information is never supposed to be lost. This puzzle is called the information paradox. It remains one of the deepest challenges in modern science. There is another mystery. Could black holes be gateways? Some theories suggest they might connect to wormholes, hypothetical tunnels through space and time. If such things exist, a black hole might be a doorway to another part of the universe, or even to another universe. But so far, this remains speculation. No proof, only imagination supported by mathematics. Black holes are not just about destruction. They are natural laboratories. They allow us to test the laws of physics under the most extreme conditions. They teach us how gravity, time, and energy truly work. When we study them, we are not only asking what they are, We are asking deeper questions. What is time? What is space? What is the ultimate fate of the universe? To understand black holes better, scientists are building new tools. The Event Horizon Telescope is one of them. It links radio telescopes across the Earth to create a virtual planet-sized lens. In 2022, this telescope released the first image of the supermassive black hole at the center of our own galaxy, Sagittarius A, a clear, glowing ring with a dark center. It was proof that the monster in our galaxy is real. Other missions, like NASA's Chandra X-ray Observatory, continue to watch black holes. They record the X-rays from matter being swallowed. They reveal the storms of energy that black holes unleash, and soon the James Webb Space Telescope will give us even more insight. Its powerful infrared eyes are already helping astronomers study galaxies in their earliest ages. Many of those young galaxies appear to hold black holes. This shows us that black holes have been shaping the universe since the very beginning. But black holes are not just distant mysteries. They are connected to our own existence, the heavy elements inside your body. Iron in your blood, calcium in your bones, oxygen in your lungs, were forged in stars. Some of those stars ended as black holes. So in a way, without black holes, life as we know it would not exist. The story of black holes is also the story of human curiosity. For centuries, humans have looked at the night sky and wondered about the unknown. Now, with mathematics, telescopes, and international cooperation, we are finally seeing the invisible. We are learning that the universe is stranger, deeper, and more beautiful than we ever imagined. Black holes remind us that even in darkness, there is discovery. Even in silence, there are answers. And even in the most extreme places, we find the fingerprints of cosmic creation. All the information we provide comes from verified historical sources, including books, records, and archaeology. Some of the key sources used are NASA official website on black holes, nasa.gov, Event Horizon Telescope publications, eventhorizontelescope.org, A Brief History of Time by Stephen Hawking, research from the Max Planck Institute for Astrophysics, peer-reviewed papers in journals such as Nature and the Astrophysical Journal. So, dear viewers, if you found this journey meaningful, do not forget to support us, like this video, share it with your friends, and subscribe to our channel, Thrones of Knowledge. Press the bell icon so you are notified on time. And please suggest our next topic in the comment section to make our journey together even better.